Imagine standing at the edge of a vast cosmic abyss where time itself begins to unravel. A place where moments stretch and compress in ways that defy everything we experience on Earth. This is the realm of black holes, enigmatic objects so dense and powerful that not only do they trap light, but they also warp the very fabric of time. For centuries, black holes existed only as mathematical curiosities in the minds of physicists, elusive to observation and bordering on the realm of science fiction. Today, they stand as some of the most mysterious and awe-inspiring phenomena in the universe, challenging our deepest understanding of reality. But what does it truly mean for time to be warped? Picture a clock, ticking steadily in your hand. Now imagine that same clock plunged near one of these cosmic beasts. To an outside observer, its ticking would slow dramatically, as if the flow of time itself were being strangled by unimaginable forces. This is no mere metaphor. According to Einstein's theory of general relativity, gravity doesn't just pull objects toward it, it actually bends space and time together into a flexible, dynamic entity we call spacetime. And black holes represent the extreme limit of this bending, creating a gravitational well so intense that it distorts time at a fundamental level. This leads us to profound questions. If time slows down near a black hole, what happens to the flow of cause and effect? If someone were to venture close to this abyss, could they witness minutes on Earth passing like hours, or the other way around? The answers are not only pivotal to our understanding of black holes but resonate through the very nature of existence, touching on questions about destiny, free will, and the possibility of time travel. Beyond the theoretical, these time-warping effects have real consequences. Astronomers have observed signals from stars orbiting the supermassive black hole at the center of our galaxy, noting how the flow of time and light behaves in these extreme environs. Probes and satellites, operating in regions of strong gravity, have confirmed subtle deviations in time's rhythm, validating this strange cosmic dance. These scientific observations imply that the universe is not a static stage where events unfold uniformly, rather, time is flexible, malleable, and intimately tied to gravity. As we prepare to journey deeper into this cosmic mystery, it's vital to set aside our everyday assumptions about time's constancy. Time near a black hole is a realm where seconds can stretch into years, where the boundary between past and future blurs and warps, and where the ordinary rules of physics begin to give way to the extraordinary. The story of how black holes warp time is more than a tale of astrophysics, it is a window into the nature of reality itself, beckoning us to explore new dimensions of space and time. In the chapters that follow, we will unravel the science behind these mind-bending phenomena, tracing the path from Einstein's revolutionary predictions to the latest discoveries captured by cutting-edge telescopes. Together, we will explore the implications for everything from the life cycle of stars to the ultimate fate of information swallowed by these cosmic giants. So lean in, and prepare to see time not as a line we travel upon, but as a river that bends and twists around the hidden monsters of the universe. Imagine standing on the edge of a vast abyss, a place where the fabric of reality itself strains under the weight of unimaginable forces. This is the environment near a black hole, a region where gravity reaches extremes that defy everyday intuition. To grasp how black holes warp time, we must first understand the subtle interplay between gravity and the flow of time, a relationship revealed through decades of scientific inquiry and theoretical insight. At our everyday scale, time seems simple and unyielding. Seconds tick steadily, moments pass predictably, and clocks synchronize without effort. But this comforting notion dissolves once we venture beyond the modest gravity of Earth into realms governed by Einstein's theory of general relativity. According to this revolutionary framework, gravity is more than an invisible pull, it is a curvature in the very fabric of spacetime, shaped by mass and energy. Picture spacetime as a vast, flexible grid stretched taut across the cosmos. When a massive object like a star or planet rests on this grid, it dents and warps the surrounding space, pulling objects and even light toward it. But more than that, this curvature alters the flow of time itself. In everyday environments, these distortions are imperceptible, so the flow of time appears constant. However, as gravity intensifies, the passage of time slows compared to regions farther away from the source of gravity. This effect, known as gravitational time dilation, means that a clock near a massive object ticks more slowly than one in a weaker gravitational field. To put this into perspective, astronauts aboard the International Space Station experience a tiny difference in time compared to those on Earth, due to weaker gravity at their orbit. Though subtle, such effects are well documented and measurable. Now, imagine stepping closer to something far denser and far more mysterious, a black hole. Here, gravity's grip becomes so overwhelming that it bends spacetime into shapes previously unimaginable. At the threshold known as the event horizon, the pull becomes absolute, nothing, not even light, can escape. It is at this boundary that the slowing of time reaches an extreme. To a distant observer, a spacecraft falling toward a black hole would appear to slow down, its clock ticking ever more sluggishly, gradually fading and freezing, seemingly suspended at the edge of this cosmic precipice. Meanwhile, the traveler crossing the horizon would experience time in a vastly different way, unaware of this external slowing even as their journey takes a dramatically different course. One way to think about this is to consider time and space as woven threads in an intricate cosmic tapestry. Near a black hole, the threads are pulled so taut and twisted so severely that the pattern of reality bends and folds, creating an environment where the familiar rules no longer apply. This subtle sculpting of time by gravity forces us to rethink our deep-seated assumptions, that time is an absolute, universal flow marching inexorably forward for all observers alike. The implications of this are profound and wide-ranging. If time dilates near a black hole, what does that mean for communication, observation, and the fate of matter crossing the event horizon? Could signals sent toward the black hole appear to stretch out indefinitely, fading into a slow blur? And how might this stretching of time affect the very nature of existence for objects swallowed by the singularity hidden within? These questions touch not only on physics but also on philosophy, on how we define reality, experience, and the flow of causality. Black holes challenge the boundary between past and future, hinting at scenarios where effects precede causes or where time loops might exist. While much of this remains speculative, the mathematical backbone provided by general relativity offers captivating glimpses into these extraordinary possibilities. It's essential, too, to appreciate the technological triumph embodied in the quest to understand these phenomena. From the earliest theoretical predictions in the early 20th century to the modern observational breakthroughs capturing the silhouette of a black hole for the first time, humanity's journey toward decoding time's malleability has been one of perseverance and ingenuity. Instruments capable of detecting subtle shifts in light and gravitational waves enable us to peer into these mysterious realms, gradually unveiling the ways black holes rewrite the cosmic narrative of time. What unfolds from this understanding transcends black holes themselves. The recognition that time bends and warps under gravity ripples through cosmology and quantum physics, fueling attempts to reconcile gravity with the laws governing the very small. Questions about how information behaves inside a black hole lead us to the edges of modern science, where competing theories strive to explain whether information is lost forever or somehow preserved, a conundrum that challenges the fundamental principles of physics. So, as we stand on the threshold of these enigmatic celestial phenomena, we realize that black holes are not merely cosmic oddities or destructive vacuums in space. They are, in a way, the ultimate laboratories for testing the limits of physics, mirrors reflecting the deep, intricate connections between space, time, and gravity. Their capacity to stretch and reshape time ignites our imagination and drives us to explore the universe not just externally but within the very essence of reality's flow. In this grand cosmic symphony, black holes act as profound distorters of time's melody, slowing its rhythm to near silence at their edges, while reminding us that our experience of time is far from universal. As we peel back the layers of this mystery, appreciating the delicate dance between gravity and time, we begin to glimpse a universe far stranger and more wondrous than we ever imagined, one where time is not a fixed backdrop but a living, changing landscape shaped by the unseen giants lurking in the darkness. To truly grasp how black holes warp time, we must delve deeper into the intricate fabric of spacetime itself, the very arena in which the universe unfolds. Imagine spacetime as a vast, flexible sheet, gently stretched and curved by the presence of mass and energy. This curvature is not merely an abstract mathematical idea but a real, physical phenomenon that dictates how objects and light move. When mass is concentrated intensely, as it is in the heart of a black hole, the curvature warps drastically, creating a region where the familiar rules of time and space begin to unravel. At the border of this region, known as the event horizon, the consequences of extreme gravity on time become starkly apparent. For an observer hovering just outside this invisible boundary, time itself appears to crawl, slowed to an almost imperceptible pace. Yet for someone venturing inward, crossing that threshold, time behaves in a remarkably different way. What seems like moments externally may stretch into an eternity internally. This discrepancy between perspectives is not a trick or illusion but a precise outcome of Einstein's theory of general relativity, which describes gravity as the distortion of spacetime rather than simply a force acting at a distance. To explore this phenomenon further, picture a clock descending toward a black hole. To distant observers watching from afar, the clock ticks ever more slowly as it nears the event horizon, its hands seeming almost frozen in place at the boundary itself. However, from the clock's own frame of reference, time flows normally, unaltered and uninterrupted. This divergence in the flow of time illustrates a key concept: time is relative, dependent on the observer's position in spacetime's curved geometry. The black hole's gravitational pull doesn't merely pull on matter, it pulls on time, stretching it like a rubber band under great tension. This leads us to one of the more astonishing theoretical implications. Near a black hole, time dilation reaches extremes that challenge our everyday intuition. The closer one approaches the black hole's core, an enigmatic point called the singularity, where density and gravity swell beyond comprehension, the time dilation effect intensifies without bound. In this realm, conventional physics breaks down, and the flow of time may become so distorted that our existing understanding falters. Extending this, we might consider the phenomenon through another lens, that of gravitational redshift, where light climbing away from the black hole loses energy and shifts toward longer wavelengths. This effect is not separate from time dilation but intimately connected. As time slows down near the black hole, so too does the frequency of light signals emanating from its vicinity. For a distant observer, signals sent from close to the event horizon are dramatically redshifted, stretched out, and delayed. It is as if time itself drags light into a languid crawl, marking the passage of seconds in ways profoundly different from those experienced farther away. In a more cosmic context, this warping of time near black holes invites us to consider how such objects can influence the evolution of galaxies, the behavior of matter spiraling around their interiors, and even the grand-scale timing of events in the universe. Around supermassive black holes, at the centers of galaxies, this temporal distortion can affect the radiation emitted by accretion disks, the swirling maelstrom of gas heated to unimaginable temperatures before they cross the event horizon. As these particles plunge inward, their emission of energy becomes entangled with these relativistic effects, producing signals that encode the time-dilated dance choreographed by gravity itself. Exploring this theoretical landscape further, physicists often employ the concept of the proper time experienced by an object moving through curved spacetime, distinct from the time measured by a distant observer. Proper time can differ dramatically depending on one's trajectory relative to the black hole. This relativity of time is one of the most profound insights into nature, revealing that time is not a universal absolute but a dimension woven into the fabric of the cosmos, sensitive to mass and energy in ways once deemed unimaginable. From the perspective of astrophysics and cosmology, these insights into time dilation near black holes also fuel speculations about temporal phenomena on a universal scale. Could black holes serve as gateways to different epochs, or act as cosmic clocks marking the rhythms of the universe in novel ways? While much remains speculative, they represent natural laboratories where time's constraints relax and warp, offering glimpses into what happens when the universe confronts its own extremes. Moreover, the principle that the flow of time can slow to a near halt invites philosophical reflections on the nature of existence itself. As time slows near a black hole, processes unfold with an altered pace, atoms vibrate, photons dance, and even the fundamental decay of particles might shift accordingly. How this impacts the very definition of now or moment challenges the linearity of time assumed in our everyday lives. By witnessing how time stretches and compresses in such extraordinary gravitational fields, we are invited to reconsider our place in a fluid, intertwined spacetime. It is also worth noting that the warping of time near black holes intersects intriguingly with the concept of causality, the idea that cause and effect follow a chain of events in a set temporal order. Near the intense gravity of a black hole, this order can become blurred, as the stretching and bending of time allows for scenarios that strain classical intuitions. While general relativity preserves causality within its framework, exploring these boundaries continues to inspire both theoretical investigation and imaginative speculation, blurring where physics ends and philosophy begins. Yet this theory is not confined to the realm of thought experiments or abstract equations. Observational evidence, gleaned through decades of astronomical inquiry, continues to confirm the profound time dilation effects near black holes. From timing pulsars in close orbit around black holes to monitoring the gravitational waves emitted by black hole mergers, scientists observe signatures that align with predictions about time's deformation. These measurements anchor our theoretical narratives in the tangible fabric of the cosmos, strengthening the bridge between mathematics and reality. Through this intricate tapestry of ideas, the main theory emerges with elegant profundity. Black holes do not merely draw matter inward, they profoundly shape the flow of time itself, creating pockets where time's speed diverges radically from its pace elsewhere in the universe. This relativity of time reveals the universe as a place where what one observer experiences as fleeting moments, another might witness as stretching eternities. It compels us to think beyond the commonplace ticking of clocks, to envision a cosmos where time's rhythm is as dynamic and mutable as the shifting stars. In embracing this theory, we unlock not only new scientific horizons but also new ways of understanding time, space, and our own existence. We come to see black holes as thresholds where the familiar universe yields to the cosmic unknown, a realm where time folds, stretches, and moves in ways that defy ordinary experience, beckoning us toward deeper comprehension of reality's enigmatic dance. To truly grasp the implications of time's distortion near black holes, we must shift our perspective to the very framework through which the universe reveals itself. Imagine time not as a universal constant, but as a fluid entity, malleable and susceptible to the presence of intense gravity. Within the immense curvature of spacetime caused by a black hole's staggering mass, the size of which can range from a few times that of our Sun to millions or even billions of solar masses, time does not simply slow in a linear manner. Instead, it follows a complex gradient that depends upon precisely how close one is to the black hole's event horizon, that invisible boundary beyond which escape is impossible. Crossing this frontier, the interplay between gravity and time reaches an unimaginable extremity. To a distant observer, time near the horizon appears to almost freeze, as if trapped in a cosmic limbo. However, local observers falling inward would experience an unbroken flow of time, unaware of any dramatic pause. This disparity defines one of the key challenges in reconciling how time operates in such extreme conditions, an insight that exposes the intimate link between perspective and physical reality itself. What emerges from this interplay is more than a curiosity, it challenges the principle of absolute simultaneity and beckons toward a new comprehension of causality. The warping of time prevents the synchronization of events in ways that contradict our everyday experience. The very order in which phenomena occur becomes relative depending on where and when you observe from. This profound breakdown of universal time chronology invites researchers to develop new logical frameworks, often in the form of quantum gravity theories, aiming to unify the seemingly incompatible domains of quantum mechanics and general relativity. Meanwhile, the consequences of such time anomalies ripple far beyond abstract theory. Take, for example, the tantalizing possibility of time capsules near supermassive black holes lurking at the centers of galaxies. It is conceivable that, due to gravitational time dilation, any processes occurring in these arenas, from star formation to high-energy particle interactions, could evolve on timescales vastly different from those experienced elsewhere in the cosmos. This means that the activity we observe, no matter how intense or violent, is but a fleeting instant in the local frame, or conversely, a protracted saga when viewed externally. Such disparities could have profound implications for our understanding of galaxy evolution and the life cycles of matter swirling within accretion disks. Further down this road of speculation lies one of the most tantalizing questions about black holes and time. Could they serve as natural gateways or conduits to regions where time flow distorts to such a degree that travel between different epochs might be possible? While mainstream physics maintains a cautious stance, the concept of wormholes, hypothetical tunnels through spacetime, arises as a theoretical extension of black hole physics. If stable and traversable, such structures might permit journeys not only across vast cosmic distances, but potentially across time itself, although the feasibility of such travel remains uncertain and entangled with unresolved paradoxes. At the heart of these investigations lies a deeper philosophical and scientific conundrum: how does the intrinsic nature of time manifest under extreme conditions? It compels us to question whether time is an emergent phenomenon arising from more fundamental processes, or a fundamental backdrop against which the universe unfolds. Black holes, in this light, are not mere cosmic curiosities but natural laboratories, offering glimpses into the laws that govern the very fabric of reality. The narrative is enriched further when we consider the role of information in these warped spacetimes. According to the laws of physics as we currently understand them, information cannot be destroyed. Yet, the classical view of black holes suggests otherwise: anything crossing the horizon vanishes irretrievably. Paradoxes like this have propelled investigations into holographic principles, proposing that the information swallowed by black holes is not lost but somehow encoded on their two-dimensional surfaces. This radical idea merges with time distortion to form a puzzle about how past, present, and future entwine at these cosmic thresholds. Observationally, the effects of time's bending near rotating black holes, the so-called Kerr black holes, introduce even richer dynamics. Spin generates frame dragging, where spacetime itself is twisted like a vortex, dragging time along with it. Objects near these rotating giants experience what is known as the ergosphere, a region outside the event horizon where energy extraction is theoretically possible via Penrose processes. Here, time dilation dovetails with angular momentum to produce phenomena that challenge our classical intuition, hinting at complex interactions between gravity, time, and angular momentum. Such nuanced effects suggest that black holes could influence surrounding matter and radiation in ways that imprint subtle signatures, ranging from shifts in X-ray emission patterns to the modulation of high-frequency quasiperiodic oscillations that we are only beginning to decode. These signals offer a window into how extremities in time flow translate into measurable astrophysical processes. Finally, the study of black holes and temporal distortion forces the human imagination to confront deep existential questions. If time near black holes bends and stretches, what does this say about the permanence of our experience, the passage of moments that shape consciousness, or the ultimate fate of information and matter? In staring into the abyss of warped time, we come face to face with a universe that resists being neatly compartmentalized, a cosmos that is as enigmatic as it is awe-inspiring. Our journey through the science of how black holes warp time reveals a realm where familiar understandings dissolve and new paradigms emerge. It challenges us to rethink the nature of time not as a simple background tick but as a dynamic, intertwined participant in the cosmic story, a story still unfolding in the endless vastness of space and time. When we begin to contemplate the profound distortions of time wrought by black holes, it becomes impossible not to reflect on what that means for consciousness itself. After all, our experience of reality is inseparable from the flow of time, the steady pulse on which memory, perception, and identity depend. But near a black hole, this pulse slows and bends so drastically that it challenges the very framework from which we grasp our existence. Imagine a traveler descending toward the event horizon, where seconds for them stretch into years for an observer far away. Their reality diverges so fundamentally from ours that questions arise: how do two conscious beings, sharing the same universe yet separated by such warped time, truly relate? Does time dilation fracture a common reality into parallel streams of experience? This brings us to a deeper philosophical inquiry about the nature of reality itself. If time is not absolute but malleable, subject to gravity and motion, then our concepts of past, present, and future begin to dissolve. Rather than a universal clock ticking forward uniformly, time becomes a local phenomenon, intimately tied to position and velocity. It prompts us to consider whether reality is singular or composed of overlapping layers, experienced differently by distinct observers moving through spacetime at divergent rates. On a cosmic scale, this may suggest that what we call the now might be far more subjective, woven from the individual vantage points of countless minds, each journeying through the ebb and flow of gravity's influence. Philosophers and physicists alike have pondered the implications of this. If time can dilate and contract, does consciousness stretch or shrink accordingly? While the physical processes near a black hole will vastly slow down neural activity for the visitor, from their own subjective standpoint, time appears normal as dreams and thoughts unfold with familiar pace. This paradox highlights the enigma of subjective time versus objective time. Our inner experience is anchored not in clock time but in the relative intervals that consciousness registers. Hence, two individuals caught in extreme gravitational fields might be living within worlds whose timelines are irreconcilable, raising profound questions about shared reality and whether now possesses any universal meaning. Furthermore, the extreme warping of time challenges our understanding of causality, the bedrock of how events unfold. Near a black hole, cause and effect may appear to stretch apart or collapse onto each other in ways alien to everyday intuition. Could events that seem future-bound to one observer appear past-bound to another? Complex theoretical models suggest that at the very edge of these cosmic phenomena, the strict linearity of time may falter, forcing us to rethink how sequences of events define meaning and structure in the universe. This hints at a cosmos where time itself might be emergent, a construct born from deeper, underlying quantum realities that do not conform to classical cause and effect. The existential weight of these revelations also casts a shadow on how we understand impermanence and legacy. If information swallowed by a black hole is preserved in some form, still debated intensely by physicists, it invites us to question notions of oblivion and permanence. What does it mean for a lifetime, a history, or a consciousness to be stretched across unimaginable timescales, only to be folded into an eternal singularity? Does the universe remember, and if so, in what form? For a human mind trying to grasp its place, this sobering mystery can inspire both humility and awe, underscoring how fragile and fleeting our moment in the cosmic theater truly is. Yet despite these mind-bending complexities, the way black holes warp time also offers a poetic lens through which to view existence. Time's elasticity near these objects mirrors the fluidity of experience, how memory can stretch, how moments can seem to flash or linger, how our personal realities are shaped as much by perception as by external clocks. It beckons us toward a view of life not as a rigid sequence of ticks but as an ever-changing interplay of moments, memories, and meanings, each uniquely compressed or expanded, relative to the observer's frame. In this way, studying black holes does more than illuminate astrophysical phenomena, it expands the horizon of human thought. It connects the cosmic to the intimate, revealing that the forces governing the farthest reaches of space are entwined with the very essence of time and awareness. We begin to see that the universe is not a cold, indifferent machine but a dynamic, evolving tapestry where time itself dances with gravity, consciousness, and reality in an endless waltz. As we stand on the literal and metaphorical precipice of this knowledge, gazing into those ancient abyssal voids, we are invited to embrace uncertainty and wonder. We realize that the flow of time we depend on, the stories we tell ourselves about existence, and the boundaries we draw between past, present, and future are all provisional, subject to the strange and beautiful laws of this cosmos. The warping of time near black holes thus becomes a mirror, reflecting not just the mysteries of physics but the profound depths of our own quest to understand what it means to be alive in a universe where time itself is fluid, elusive, and endlessly mysterious. Beyond the grandeur of swirling stars and the unforgiving pull of gravity lies an even darker realm of possibility, one where time itself becomes a conduit for paradox and the unknown. As we peer closer into the shadowed edges of black holes, these enigmatic titans reveal unsettling implications that challenge conventional notions of beginnings and endings, cause and effect, even reality itself. Consider the possibility that these cosmic wells are not simply destructive forces, but gateways, thresholds to regions where the laws of physics as we understand them come unraveled. Within the inscrutable depths beyond the event horizon, time might not simply slow or warp, it could break down into something altogether alien. The classical arrow of time, the unidirectional flow from past to future, may dissolve here, replaced by loops, twists, or even reversals. This opens a stunning yet deeply disconcerting question: could black holes harbor pockets of spacetime where moments fold back on themselves, generating cycles without discernible origin or terminus? If so, what does it mean for concepts like causality and free will, the very pillars upon which we build our understanding of the universe and our place in it? Furthermore, some theoretical frameworks suggest that black holes might act as cosmic memory banks, encoding the information of everything they've consumed in an intricate holographic pattern on their event horizons. This radical notion hints that no information is ever truly lost, yet paradoxically trapped in a realm inaccessible and inscrutable to outside observers. If time near a black hole becomes so distorted that the fate of particles, radiation, and photons intertwine in infinitesimal detail, could this entanglement serve as the universe's own dark ledger, an encrypted record of history written in the language of warped spacetime? The unsettling aspect is that what we perceive as the end, matter swallowed forever, might instead be a transformation into something we cannot yet comprehend, stored in a form both timeless and beyond reach. Even more provocatively, some cosmological hypotheses explore the idea that black holes could be seeds of new universes, budding off entirely distinct realms of space and time. In this scenario, the warped flow of time inside a black hole might be the genesis of an embryonic cosmos, expanding outward in its own temporal dimension, disconnected from our own reality. This possibility reframes black holes not merely as devourers of matter and time, but as creators, breeding grounds for fresh cosmic epochs. Yet this comes at the cost of accepting that what falls through the event horizon never truly disappears but is effectively removed from our spacetime continuum, giving rise to a shocking duality where collapse births creation. Amid these unsettling theories, the very fabric of now is called into question. Around black holes, the distinction between past, present, and future blurs, rendering the flow of time a fluid concept rather than a fixed backdrop. This challenges human intuition rooted in sequential progression and forces us to grapple with a universe where temporal order may be emergent rather than fundamental, where time could be shaped by forces and phenomena vastly different from everyday experience. Such a realization has profound philosophical implications. If time is not absolute, if it shifts and bends under gravity's extreme influence, then the stories of history, memory, and destiny become multifaceted and possibly fragmented, their coherence dependent on one's position in the cosmos. Moreover, emerging research into quantum gravity and black hole thermodynamics hints that time's warping might come hand in hand with quantum uncertainty and entropy in strange and surprising ways. Near a black hole, time's dilation stretches the lifespan of quantum processes, creating a regime where classical cause and effect melds with probabilistic outcomes. This symbiosis fuels a mysterious interplay between determinism and chance, inviting speculation on whether the universe contains hidden layers of time, multiple temporal dimensions or scales intertwined, some accessible only through the prism of extreme gravity. All of these enigmas invite a humbling perspective on human knowledge. Black holes, once imagined as simple cosmic vacuum cleaners, have become profound objects of study that expose fissures in our understanding of time, reality, and existence. Their influence extends beyond the astrophysical realm into metaphysics and epistemology, beckoning us to embrace not just the measurable and calculable, but also the unknowable, the paradoxical, and the mysterious. In confronting these dark possibilities, we recognize that black holes stand as silent sentinels at the boundaries of science and philosophy. They compel us to rethink time not as a universal metronome but as a dynamic, malleable phenomenon, one that may harbor secrets about the origins of reality itself, the fate of information, and the emergence of new realms beyond our perception. As our instruments of observation and mathematics grow ever more sophisticated, we inch closer to unraveling these mysteries, and yet, with each answer, the shadows deepen, revealing ever stranger landscapes where time itself contorts, folds, and perhaps even ceases to exist as we know it. In this dance on the edge of understanding, black holes remain both harbingers of cosmic doom and gateways to the deepest, darkest secrets of existence. They invite us to journey inward with a sense of awe and caution, reminding us that the universe contains mysteries beyond imagination, where time bends in ways that challenge not just physics, but the very nature of reality. As we close this exploration of how black holes warp time, it becomes clear that these cosmic phenomena are much more than distant enigmas. They are profound mirrors reflecting the complexities and wonders of the universe itself. The stretching and slowing of time near a black hole is not merely a curiosity confined to equations or theoretical models, it resonates deeply with our very experience of existence. Imagine a single second, elongated into an eternity, or conversely, an eternity compressed into a fleeting instant. Through this lens, time loses its familiar rigidity, revealing a fluid, almost poetic quality that challenges the core of our intuition. Consider, for a moment, the implications for life itself. If an explorer somehow hovered near the edge of a black hole, witnessing the universe beyond racing forward at an unimaginable pace, what would it mean to experience time so differently from everyone else? This perspective invites us to ponder the subjective nature of reality, where moments might carry entirely different weights and meanings depending on where or when we find ourselves in the vast cosmic stage. It stirs the imagination, opening doors not just for science fiction, but for profound philosophical inquiry. How does consciousness perceive time? Is our linear experience simply a slice of a far grander temporal tapestry woven by the cosmos? Furthermore, the interplay between gravity and time near these gravitational titans challenges the way we approach the laws that govern everything we observe. Time dilation around black holes suggests that spacetime is a dynamic fabric, shaped by matter in ways that ripple beyond the realms of everyday experience. This realization fuels a deeper quest to unify Einstein's theory of relativity with quantum mechanics into a coherent theory of quantum gravity. Such a breakthrough would reshape our understanding of the universe, potentially unlocking secrets about the birth of time itself, the nature of singularities, and perhaps even multiple dimensions or parallel realities. The warping of time near black holes also has implications for how we interpret the cosmic timeline. If time behaves differently in regions of extreme gravity, then the narrative of the cosmos, from the Big Bang to the distant future, may not unfold uniformly. This fracturing of temporal experience calls us to rethink how events are sequenced on a grand scale, affecting our models of cosmic evolution and the fate of everything within it. In this way, black holes become not just endpoints or destructive forces, but dynamic participants in the ongoing story of the universe, shaping the flow of time and energy across unimaginable expanses. On a more human level, the concept that time can slow down to a crawl near a black hole offers a profound metaphor for our own encounters with moments of crisis, transformation, or wonder. Just as gravity can stretch the fabric of time, so too can life's pivotal moments stretch and expand our perception of reality. This parallel invites us to reflect on how we engage with time in our daily lives, not as an abstract, unchanging force, but as something pliable, alive, and deeply intertwined with the experiences that define us. Ultimately, black holes compel us toward a humbling recognition of our place within the cosmos. They reveal the limits of our knowledge, but also the boundless potential for discovery and understanding. In the shadow of these gravitational wells, time becomes a bridge connecting the tangible with the mysterious, science with philosophy, and the known with the unknown. This invitation to embrace complexity and uncertainty enriches not only our scientific pursuits but our sense of wonder, a reminder that the universe is far stranger and more beautiful than we have dared to imagine. As we step back from the edge of a black hole's time-distorting embrace, we carry with us a new appreciation for the mutable nature of time and space. The journey has shown that time is not simply the silent river we all float upon, but a living, breathing dimension, worked and shaped by the universe's most extreme forces. It is a testament to the profound interconnectedness of all things, where the dance of gravity and time reveals secrets as ancient as the stars and as deep as the void. In this unfolding cosmic story, black holes remain enigmatic sculptors of time, molding it, bending it, and challenging us to perceive reality in ways once thought impossible. As our gaze extends ever further into the cosmos, they stand as perpetual reminders that the universe is both our grandest frontier and our most profound teacher, inviting us to keep questioning, exploring, and dreaming beyond the boundaries of time itself. Beyond their well-known ability to trap light and matter, black holes exert an even more subtle and profound influence on the fabric of time, a phenomenon whose effects ripple through the cosmos in ways both eerie and illuminating. Imagine for a moment the experience of an intrepid traveler venturing closer to the event horizon, the invisible boundary beyond which escape becomes impossible. For this traveler, time unfolds differently than it does for an observer safely distant from the voracious gravity. What unfolds here is not mere science fiction but a genuine consequence of Einstein's theory of general relativity, where gravity warps spacetime and alters the very flow of time itself. To grasp this, let us use an analogy grounded in the rhythms of a clock. Picture two identical clocks ticking in unison, one far from any massive object, marking time steadily, and the other descending toward the edge of a black hole. As the second clock approaches this gravitational abyss, its ticking slows in comparison to its companion. From the distant observer's vantage point, it seems almost suspended, advancing at a sluggish pace, as if the black hole's gravity stretches time itself. The closer the clock gets to the event horizon, the more pronounced the slowing becomes, approaching a standstill at the very brink. Yet, for the traveler themselves, the ticking beats on with perfect normalcy. This disconnect between perspectives highlights a fundamental truth: time is not absolute but deeply entwined with gravity. But this is only part of the story. The intricacies deepen when we consider rotational black holes, or Kerr black holes, which introduce a new layer of complexity through a phenomenon known as frame dragging. In these cosmic maelstrom, spacetime itself is pulled around in a cosmic whirlpool, twisting and dragging everything along with it, including the flow of time. It's as if the black hole's rotation spins not just matter, but the very threads of time, making the passage of moments as malleable as the spinning currents of a turbulent sea. Objects caught in this swirling grip experience time in ways that defy conventional intuition, revealing a dynamism to the universe that is at once alien and captivating. Such effects have profound implications not merely for theoretical physics but for the practical aspirations of deep space exploration. Hypothetically, a spacecraft venturing near a rapidly spinning black hole might witness time dilation so extreme that mere hours could translate into years outside its vicinity. While current human technology remains far from achieving such proximity or withstanding the searing forces encountered, these scenarios fuel speculation about future interstellar voyages, and even about the possibility of using black holes as cosmic clocks or portals in the fabric of spacetime. At a cosmic scale, the warping of time around black holes also plays a crucial role in the life cycle of the universe. The energetic phenomena linked to black holes, jets of charged particles accelerating to near-light speeds, powerful bursts of X-rays, are all part of interactions that unfold within the framework of time's distortion. These processes can regulate star formation, influence the dynamics of entire galaxies, and perhaps even affect the distribution of matter throughout the cosmos. By warping time, black holes help orchestrate the cosmic symphony, their gravitational influence stretching across vast distances and epochs. Bringing this perspective closer to home, one can reflect on how the extreme time variations induced by black holes challenge our everyday notions of causality and sequence. If the flow of time can vary so dramatically depending on one's position relative to a gravitational giant, then questions arise about how events interrelate across time and space. This has led scientists and philosophers alike to re-examine the idea of a universal now, compelling a shift toward a more relative, observer-dependent worldview, a shift that echoes from the microscopic scales of quantum mechanics to the macroscopic scales of cosmology. Yet, as enthralling as these ideas are, many mysteries remain. What happens to time inside the black hole's event horizon? Does time cease, reverse, or undergo transformations beyond our current understanding? The frontier of these questions lies at the intersection of general relativity and quantum mechanics, a domain where new physics may one day emerge. The science of black holes, then, is not only about understanding the universe's most extreme objects but about probing the foundations of reality itself. As we contemplate the cosmic clockwork influenced by black holes, another intriguing concept emerges, that of gravitational redshift and its intimate connection with time dilation. Observers far from the black hole perceive signals, whether light or radio waves, emitted near its event horizon to be stretched and shifted to longer, lower energy wavelengths, as if time near the black hole is moving more slowly. This phenomenon adds a layer of observational evidence that bridges theoretical predictions with astrophysical data, enabling researchers to test and refine models of spacetime warping. In this light, black holes serve as natural laboratories, places where the otherwise imperceptible passages of time are magnified and laid bare. By studying the timing of pulsars orbiting black holes, or the echoes of light trapped in gravitational lensing, scientists can measure the warping of time with remarkable precision. Such observations have brought us closer than ever to visualizing the intimate dance between gravity and time, opening windows onto realms where time folds, flows, and falters. Thus, the influence of black holes on time is not a mere curiosity of astrophysics but a profound chapter in our ongoing quest to understand the universe's structure and evolution. It inspires us to ponder a reality where time is as variable and dynamic as space itself, where seconds can stretch into eternities or contract to fleeting instants. In this ever-shifting theater of gravity and time, black holes stand as both enigma and teacher, urging us to reconsider the very nature of existence and the intricate fabric from which it is woven. As we peel back the layers of how black holes manipulate time, an even deeper question emerges, one that nudges us beyond physics and into the realm of philosophy. What does it truly mean for something to exist in time? Our everyday experience clings tightly to the notion of time as a steady, universal flow, an invisible river that carries us relentlessly forward. But near a black hole, this current becomes turbulent, folding in on itself, bending, and slowing to a crawl. If time can stretch and compress depending on perspective and gravity, what does this reveal about the fabric of reality itself? Consider consciousness, the very awareness through which we perceive time's passage. It's often assumed that the mind experiences time uniformly, as an unbroken thread connecting past, present, and future. But if time is relative, if it can warp under immense gravitational forces, then consciousness, as we understand it, might also be more fragile, or more expansive, than we imagine. Are we confined to a linear timeline because of our human scale and environment? Or might consciousness itself be capable of broader temporal experiences, limited only by the physical conditions of spacetime? Black holes, in this sense, challenge the way we define existence. If an astronaut could orbit close enough to a black hole, her minutes might equate to years on Earth, a startling discrepancy that defies intuitive understanding. To her, time ticks normally; to distant observers, it drags or even seems to halt. Does this mean she inhabits a different reality, one where the rules of time break down or reshape? And if so, does that reality carry the same ontological weight as our own? It's a question that unsettles the certainty of human experience and invites us to reconsider what it means to live or be in any given moment. The notion of time's malleability near black holes also prompts reflections on memory and history. Our past is inseparable from the progression of time; it is how we anchor our identities and stories. But if time can stretch or compress, what happens to that chain of cause and effect upon which so much of meaning is constructed? In environments where time nearly halts, does memory become frozen or fragmented? Are events eternally suspended in an unchanging now, or does the flow of experience itself begin to unravel? Beyond purely intellectual musings, these considerations hint at a cosmic humility. Black holes expose the limits of human perception and cognition, reminding us that our grasp of time is but a sliver of a far vaster and more complex reality. What we experience as the relentless flow of moments might be nothing more than a localized phenomenon, a comforting illusion formed in the familiar gravitational fields of Earth and the solar system. In the presence of such titanic forces, the universe reveals its astonishing capacity for diversity and strangeness, a reminder that the cosmos is not designed for ease of understanding but thrives on mysteries that stretch the imagination. This perspective also has a poetic resonance. The warping of time near black holes mirrors the ebb and flow of human life, the way seconds can feel infinite in moments of joy or despair. Within the gravity wells of our own experiences, time can take on new meanings, contracting in nostalgia or expanding in anticipation. Perhaps, by studying black holes, we are also holding up a mirror to the rhythms of consciousness itself, glimpsing the intricate dance between gravity, time, and awareness. As we stand on the cusp of new explorations, both scientific and philosophical, it becomes clear that black holes are not just celestial objects hidden in cosmic darkness. They are profound invitations to rethink the nature of time, the boundaries of reality, and the very essence of what it means to be. In their mysterious depths, they whisper to us that time is alive, dynamic, and intricately woven into the universe's broader narrative, a narrative we are still learning to read, line by line, moment by moment.